Okay, so in this video we're going to look at multiplying radicals. So the cool part is you basically already know how to multiply radicals. So let's just look at a real quick example. Say you have square root of 45. We've worked with this in simplifying radicals. Square root of 45 I can rewrite as square root of 9 times square root of 5 to give me 3 square roots of 5. Well, if I can rewrite one way, meaning I can break up square root of 45 into two different radicals, that's square root of 9 times square root of 5, then that means I can go the other way. If I have a square root of 9 times the square root of 5, I have to be able to go backwards to the square root of 45. So when I'm multiplying radicals, I'm really just multiplying the things on the inside of the radical. So if I have a square root of 2 times the square root of 3, I'm just multiplying them together to get square root of 6. Well, what if we have stuff on the outside and inside of radicals, such as 5 square roots of 6 times 2 square roots of 5? We dealt with that when we were combining radicals. We multiplied the stuff on the outside together, and we multiplied the stuff on the inside together. So if I want to, I can rewrite it. Multiplication is commutative, meaning you can switch the order. So I could rewrite this as 5 times 2 times square root of 6 times square root of 5. So I would just get 10 square root of 30. You do always want to check to make sure that your radical isn't simplifiable or you can't simplify it. So I'm going to go ahead and do a quick factor tree. 30, 10 and 3, 5 and 2. So no, I would be able to rewrite 30 as 5 times 2 times 3. None of that is anything squared, so I couldn't take the square root of it. So 10 square roots of 30 is good. You can check it an easier way. If you have square root of 6 times square root of 5, square root of 6 would factor to 2 times 3. That times square root of 5 is not going to give you anything squared, so you can kind of know that this is not going to be simplified. So let's try another one. Say we have 3 square roots of 2 times 5 square roots of 6. You can rewrite it if you want to. I'm not going to this time. I'm just going to say, okay, I know the stuff on the outside has to be multiplied together. So 3 times my 5 is going to give me 15. Square root of 2 times square root of 6 is going to give me square root of 12. I can rewrite square root of 12. I would get 15 square roots of 4 square roots of 3. So 15 times 2 square roots of 3, so 30 square roots of 3. Always make sure everything is simplified. So again, we could have done this a little bit of a different way. I know square root of 6 is 2 times 3, so when I multiply my square root of 2 times my square root of 6, I could have written it as 15 square roots of 2 squared square root of 3. I would have gotten the same thing. The 2 squared would have canceled out to give me the 15 times 2 square roots of 3. Up to however really you think about it. So let's try another one. Say I have 2 square roots of 5 times 6 square roots of 2 minus 4 square roots of 10. I'm going to take my 2 square roots of 5, I'm going to distribute it times both things in my parentheses. So I'm going to write it out for the first time. 2 square roots of 5 times 6 square roots of 2 minus 2 square roots of 5 times 4 square roots of 10. So the first thing should give me 12 square roots of 10. The second one should give me 8 square roots of 50. Square root of 50 I can rewrite as 25 times 2. So square root of 25, square root of 2. 8 still on the outside. Might as well write the 12 square roots of 10 over here to keep everything really nice. So I should keep 12 square roots of 10 minus square root of 25 is just 5. So 40 square roots of 2. If you saw it that other way, if you saw that 10 broke into 5 times 2, and you rewrote it really quickly as 25 times 2 or 5 squared times 2, then great. Continue doing it that way. Okay, so let's try another one. 3 square roots of 6 times 4 square roots of 2 minus 7 square roots of 8. So again, I'm going to distribute. I'm going to take this and multiply it times both parts. If I take my 3 square roots of 6 and multiply it times 4 square roots of 2, I'm going to get 12 square roots of 12. 3 square roots of 6 times minus 7 square roots of 8 minus 21 square roots of 48. Okay, I'm going to simplify. So 12 could be square root of 4 times square root of 3. I got 12 still on the outside. Square root of 4 is 2, so I'm going to have 24 square roots of 3. 48 can break down a few ways. 4 goes into it 12 times. 16 also goes into it. So I'm going to do 16. And 16 will go into it 3 times. So 6 square root of 16 is 4. 21 times 4 should be 84 square roots of 3. Now if I look at this, I have like terms. I have square root of 3 and square root of 3. So 24 square roots of 3 minus 84 square roots of 3 should be minus 60 square roots of 3. And now I'm done. So let's look at the next one. Say we have 2 square roots of 5 plus square root of 3. That binomial times 4 square roots of 6 minus 3 square roots of 11. Binomial times a binomial means I'm going to FOIL. So I'm going to take my 2 square roots of 5 and multiply that through. 2 square roots of 5 times 4 square roots of 6 should give me 8 square roots of 30. 2 square roots of 5 times minus 3 square roots of 11 should be minus 6 square root of 55. Okay, so now I'm going to move to my next part, my square root of 3, and multiply that all the way through. Square root of 3 times 4 square roots of 6 should be plus 4 square root of 18. And square root of 3 minus 3 square roots of 11 times minus 3 square roots of 11. So minus 3 square root of 33. I'm going to see if anything can be simplified. 30 we already discussed before. Cannot. So that's going to stay. Square root of 55, if I did prime factorization, I would just get 5 and 11. So that's going to stay. Square root of 18, though, I can simplify. That'd be square root of 9 times square root of 2. 4 still on the outside. So 12 square roots of 2. 33, if I did prime factorization, would be 3 and 11. So that would also stay. So the only one that could be simplified was that square root of 18. So I'm going to rewrite everything else. Let's try one more. Say I have 5 square roots of 6 minus 3 square roots of 2 times 6 square roots of 3 plus 2 square roots of 10. I'm going to start off with my 5 square roots of 6. That times 6 square roots of 3 should give me 30. Square root of 18, which I already know can be simplified, so we'll be coming back to it. 5 square roots of 6 times 2 square roots of 10 would be plus 10 square roots of 60. Now I'm going to go to my second part, FOIL, so I'm multiplying that through. Minus 3 square roots of 2 times 6 square roots of 3 would be minus 18 square root of 6. Minus 3 square roots of 2 plus 2 square roots of 10 minus 6 square roots of 20. See what can be simplified. Square root of 18 would be square root of 9 times square root of 2. 30 on the outside. Square root of 9 is 3. So I'm going to get 90 square roots of 2. 60 could be broken into 10 stays on the outside. Let's see, 4 and 15. Square root of 4 is 2. So plus 20 square root of 15. Square root of 6 I can't do much with, so I'm just going to bring it down. Minus 18 square root of 6. Square root of 20 I could break into square root of 4 times square root of 5. 6 stays on the outside. Square root of 4 is 2, so I should get minus 12 square roots of 5. Check to see, do I have any like terms? No. So this is it. Okay, let's look at this one over here, the 2 square roots of 5 plus square root of 3. That's squared. I know whenever I'm squaring a binomial, that I have to sit there and actually write it out twice and FOIL it. That was on, I don't know, a way earlier lesson. Probably multiplying polynomials. Okay, so if I do this, I'm going to take my 2 square roots of 5 and distribute it. So 2 square roots of 5 times 2 square roots of 5 would be 4 square roots of 25. 2 square roots of 5 times the square root of 3 would be 2 square roots of 15. Now I'm going to take my square root of 3 and distribute that. So square root of 3 times 2 square root of 5 would be 2 square root of 15. Square root of 3 times square root of 3 would be plus square root of 9. So I'm going to get 4 times square root of 25. Square root of 25 is simplifiable, that's just 5. So 4 times 5, or 20, plus 2 square roots of 15, plus 2 square roots of 15. 15 is not simplifiable. Plus square root of 9. Square root of 9 is just 3. So I have some like terms here. I have my numbers, 20 and 3, should just give me 23. And I have the same base, same number raised to the same power. So I have 4 of those square roots of 15. And that's it. So notice real quick that when I FOILed this, because I squared something, it was the same thing multiplied by itself. So my 2 square roots of 5 times my 2 square roots of 5 became 2 squared, which was 4, times square root of 5 squared. If I wrote out square root of 5 squared, that square and that square root would cancel each other out. They're still opposite operations. I would just have the 5. And that's what I got. I had the square root of 25, which came down to 4 times 5. Same thing with my square root of 3. My square root of 3 times square root of 3 became square root of 3 squared, which again would just cancel each other out and become 3. When I multiplied them, I got square root of 9, which of course is just 3. So we're going to keep that in mind for the next two problems. So say I have the square root of x minus 1 plus 1, and I want to square that. I'm going to start off the same way. I'm going to write out two binomials, square root of x minus 1 plus 1 and square root of x minus 1 plus 1, and I'm going to FOIL it. Square root of x minus 1 times square root of x minus 1 just seems evil. So I'm going to write it as square root of x minus 1, something times itself, so squared. I'm going to work the rest of the problem. So square root of x minus 1 times 1 would be plus 1. Square root of x minus 1. Now I'm going to take my 1 and distribute that through. So 1 times square root of x minus 1 is 1 square root of x minus 1. 1 times 1 is plus 1. So now square root of x minus 1 squared, they again are going to cancel each other out. So I'm going to get x minus 1 plus, hey look, I got like terms here. 1 square root of x minus 1 plus 1 square root of x minus 1. 2 square roots of x minus 1 plus 1. And I got like terms still. Minus 1 and plus 1 will just cancel each other out. So I'm going to get x plus 2 square roots of x minus 1. And that's it. Let's try the last one. Square root of x minus 3 minus 2. That binomial squared. So I'm going to write it out. So square root of x minus 3 minus 2 times square root of x minus 3 minus 2. And I'm going to FOIL. So I'm going to take my square root of x minus 3 and distribute it. So square root of x minus 3 times square root of x minus 3 again seems evil, but since it's something times itself, it is square root of x minus 3 squared. So square root of x minus 3 times minus 2 square roots of x minus 3. Now I'm going to take my minus 2 and distribute that. So minus 2 times square root of x minus 3 would be minus 2 square roots of x minus 3. And minus 2 times minus 2 would be plus 4. Simplify. So square root of x minus 3 squared would cancel the square root and square it out. So x minus 3. Again, I have like terms. So minus 2 square roots of x minus 3 and minus 2 square roots of x minus 3 would be minus 4 square roots of x minus 3 plus 4. And I still have like terms. My minus 3 and my plus 4 would simplify to a plus 1. So x plus 1 minus 4 square roots of x minus 3. And that is it. We are going to use this a lot in future videos on rationalizing and solving.